Formation of SF6 molecule based on valence bond theory and hybridization. The central atom is sulfur. Atomic number 16. Let's write the ground state electronic configuration of sulfur. 1s2, 2s2, 2p6, 3s2, 3p4. We need only the valential electronic configuration. 3s2, 3p4. 3s orbital, the orbital diagram. 3s orbital with 2 electron. 3p with 4 electron. How to arrange 4 electron? 1 electron, 1 electron, second electron, third electron, fourth electron pair in the first. So this is the orbital diagram electronic configuration of sulfur in the ground state. See how many unpaired electrons here? Only 2 unpaired electrons. It contains only 2 unpaired electrons, which is not sufficient to make bond with 6 fluorine atoms. Sulfur need to form 6 bond with 6 fluorine atoms. So actually it need 6 unpaired electron, but now it contains only 2 unpaired electron. So what happens here? Sulfur go to excited state. At the time of bonding with the 6 fluorine atom, the sulfur atom absorb energy and get excited. So the electron, the paired electrons in the 3s, paired electrons in the 3s and 3p. One of the paired electron jump to the empty 3d atomic orbital. There are 5 3d atomic orbitals which are empty. So one of the 3s electron jump to the 3d atomic orbital. And one of the 3p electron also go to the 3d atomic orbital. So the excited state electronic configuration, 3s only 1 electron, 3p with the first orbital 1 electron, second and third the same. And now in the excited state, 2 of the d atomic orbitals contain electron. So in the excited state there are how many unpaired electrons? There are 6. 6 unpaired electrons are available now in the excited state of sulfur. Now these unpaired electron containing atomic orbitals will undergo hybridization. Which hybridization? 1 s orbital, 3 p atomic orbital, 2 d atomic orbital. So the hybridization is sp3d2 hybridization. And this hybridization result in how many hybrid orbital? Because 6 atomic orbitals undergo hybridization, 6 hybrid orbitals are produced. We know all the 6 hybrid orbitals have the identical shape, one larger lobe, one smaller lobe. And all the sp3d2 hybrid orbitals are half filled, contain 1 unpaired electron each. Now how these 6 hybrid orbitals occupy in space around sulfur. So this is our sulfur atom. Around sulfur there are 6 sp3d2 hybrid orbitals. They would occupy along the 6 corners of a regular octahedron. Octahedron contains a square plane in the middle. Out of 6 hybrid orbitals, 4 occupy along the 4 corners of a square plane. And the remaining 2, one above the square plane, one below the square plane. So all these are sp3d2 hybrid orbitals. They contain 1 electron. Half filled sp3d2 hybrid orbitals orient along the 6 corners of an octahedron or a square bipyramidal. And each of the half-filled sp3d2 hybrid orbitals now would overlap with the fluorine orbital. Fluorine atomic number 9, the electronic configuration of fluorine can be written as 1s2, 2s2, 2p, 2s2, 2p5. This is the configuration. 2s with the 2 electron, 2p5. 1, 2, 3, 4, 5. Now here it contains a p atomic orbital. which is half filled. So each of the sp3d2 hybrid orbitals would overlap with the half filled p atomic orbital of fluorine atom. So this be the half filled p atomic orbital of fluorine. So this result in sharing. There are 5 fluorine atoms. So there are 6 fluorine atoms. So each of the sp3d2 hybrid orbital would overlap with the half filled p atomic orbital on 6 fluorine atoms. This overlapping result in sharing and hence formation of covalent bond. This overlapping result in, this is axial overlapping, hence it will result in sulfur fluorine sigma covalent bond. Sulfur at the center of the octahedron. Sulfur is at the center of the square plane, and out of 6 sulfur fluorine bond, 4 along the corners of the square plane, and the remaining 2, one above, one below the square plane, perpendicular to the square plane, and on joining the corners we get an octahedron. So a pyramid above, similarly a pyramidal plane below. Square, the geometry is square bipyramidal or octahedral. And each of the fluorine sulfur fluorine bond angle is 90 degree. All the bond angles are equal.